Now, as usual, if you have any questions, feel free to interrupt me at any point with the voice or the chat. I'm only recording my audio as well as my screen, so you won't be part of the recording. So I'm going to go over some stuff with transformation. We're going to look at a few different examples. I'm going to get the P5 editor open. So I'm just going to go to editor.p5js.org. And I'm already logged in, so that's good. I'm going to increase the size of the text here. And just to kind of review what we did on Monday real quick, I'm going to open up the example we did Monday. So I won't go through everything, but just to show basically what we added in here. Um, so I didn't really update the meme itself, but I just gave an example of animating something. So I'm looping the text down here around. And so that's just one example of the different types of animations that we looked at on Monday. And there's some more examples in the uh, video and the examples from then. But basically what we're going to do is we're going to look at another type of animation where we're going to animate different types of elements. So we're going to do something very similar, but we're going to add a new concept that we haven't covered yet this semester, which is actually a pretty useful thing to be able to do. And it's kind of random that this is when we're talking about it. It's something that we could bring up early in the semester or later in the semester, but it's kind of useful to pair here. So you don't have to use transformation and animation together, but I'm just combining them in this case to use them kind of to, uh, sort of work together. Um, but we're going to do something very similar to this, basically to create this little I'm a dog, I'm a sad dog looping text down here. It's very simple animation. We just use this variable x equals 200. So we have to declare the variable at the beginning of the program so that it's persistent. It exists even though we're redrawing over and over again. And then down here in the draw function, this is basically our animation right here. So we're taking the text, and then after we draw the text, we're drawing that text at x. Excuse me. And after we draw the text, we're increasing the value of x. So we're moving x across the page each time we draw our meme. And then if we get to a certain point, which is if x goes 100 pixels beyond the side of the canvas, then we're resetting and setting x to the left side of the canvas. So we're setting x to negative 100. And so what we'll look at today is how we can do that with transformation. And so transformation actually lets us kind of reset the canvas itself and do different things with the canvas. So we can create scale, rotation, we can do lots of different stuff with it. So what I'll do, actually, I want to see if I have well, actually I can modify this. So I'm going to duplicate this meme and make another example here. So I'll call this meme 2 example. And let's see, this is the 22nd. So I'll update this in a little bit, but before we do that, we're just going to go over some of the basics with transformation. So I'll go ahead and open up another P5 window in case I want to show some stuff over here. And let's go back to our notes. Okay, so we're talking about transformation. This is a new topic. We haven't gone over any of this stuff really before. And what we can do with transformation is we can actually transform the canvas itself. So that's the real big difference in what we're talking about tonight versus what we've talked about in previous classes. So we've done a lot of stuff with the default canvas. We can draw shapes and we can give them different colors. We can draw text and images and we can put them all over the canvas and, kind of design that way. But with transformation, we can actually change the canvas itself. So we can change where the origin of the canvas is. We can change the size and the rotation and the scale and other parameters with the canvas itself. And so there's a bunch of different functions that let us do this. One of those functions is translate. Um, and this is a link to the P5 documentation, obviously, for this function. And essentially what this does is it just allows us to translate the entire canvas to a different origin. And so I have an example of this here, an interactive example. You can see the default origin of the canvas is the top left. And so in this code here, rectangle at 10, 10, 50, 50, you can see that this rectangle is being drawn up there where 10 is 10x, 10y. And then this ellipse over here is drawn a little bit farther in, 100x, 100y. And if I translate x, you can see what happens. The same drawing, the same code is getting moved to a different place. Um, and so with translate, you might say like, okay, that's fine, but I could just move, I could just change the position of the shapes. But what we're going to see as we add different transformations together, that translate is necessary to make some of the other uh, transformations work correctly. So let's show a quick example of this in the editor. So I'm going to just basically make a similar example. So I'm going to let's draw a rectangle. So I'll draw a rectangle at 10, 10, and I'll make the size 100 by 100. And so that's the default with P5, where basically here's our 0 point in our coordinate system, and x obviously gets bigger going this way, y gets bigger going this way. And so this point right here is 10x, 10y. And then we have a rectangle that's, 100 pixels wide and 100 pixels tall. And so if we translate, we're going to move that origin point. So you're going to see I'm not going to change the rectangle at all. I'm not going to change the x and y position of the rectangle. What I'm going to do instead is I'm going to translate. So before I draw my rectangle, I'm going to say translate. Got to spell it right though. And let's translate to the middle of the canvas. So I'll translate to 200x, 200y. And so I didn't change the rectangle code at all, but now we see the rectangle has shifted down in the canvas. So we can translate the entire canvas. And I don't have to translate, by the same value. I could translate just on x. So I could do 200 on x and leave y the same. Or, vice versa, I could do 0 on x and 200 on y. And so now we'll translate down. So a couple quick examples here before we go back to our notes. The translate function and the other transformation functions work the same way that the fill and the stroke functions work, whereas the order is important. So if we have fill and then stroke and then we draw a circle, then we'll apply the fill and the stroke to that circle. And then if we change the fill and stroke later, obviously it's going to change where it gets applied. So if we move this translate function down a little bit, so now I'm drawing the rectangle first, you're going to see it no longer affects that rectangle. So if we drew another rectangle down here, in fact, I can draw the exact same rectangle. I'm just going to copy this code and paste it down here. So now you can see the first rectangle is not translated, whereas the second rectangle is translated. So just like our other functions, fill and stroke, and text properties as well, our translate function, the order matters. It only applies to things that come after. The translate function is also additive. So if I were to translate up here, let's say I translated 50, 50, or let's actually just translate over by 100. Oops. Oh, I have to put another parameter here. Okay. So now the translate is additive. So you can see that the first rectangle is just using the first translate. So I start at 0, 0, which is here. And then the first translate is just x goes over by 100 and y is 0. So I move to 100x, which is right here. And then I draw my first rectangle at 10x, 10y. And then I'm translating again. So this translate adds on to the first translate. So I'm going another 200 this way and then 200 down. So I'm moving each time 0, 0, the origin of my canvas is moving. And I can translate negative as well. So if I wanted to like undo that translate, I could do like something like this, negative 100, 200. So you can translate back and forth. You can, translate around to different positions. Any X, Y position that you can translate to, you can do that. And you can use it as many times as you want. And they kind of get stacked on top of each other. They don't have to. We'll look at a way to not do it that way in a little bit. But just getting started, we can see that they add together if we add more translate functions. Okay, so that's translate. That's kind of the most basic one. And as I mentioned, we can just move our shape. So we don't really need to use translate unless we're using it in conjunction with other transformation functions. Or there's some other context where you might want to use it. But in this case, we're going to use it with other transformation functions. Um, so let's continue. We kind of looked at that. So rotate is the next one that we're going to look at. And this is where we'll see rotating the entire canvas around. And so rotate is basically just what it says. We can rotate. And usually, kind of like our arc, we're going to measure our rotation in terms of pi, pi being the mathematical constant that we use to measure the radius and diameter of circles. Um, so the rotate function is pretty simple. It just takes one parameter, which is how far around a circle we want to rotate. And we can use it with translate to change the origin of the rotation. So that's where translate gets important. So let's look at a little example here. And then we'll add some code into our P5 example. So in this one, in this example here, we're translating to XY, and then we're rotating by R. So R is just going to be short for rotation. And then we're drawing our same rectangle and ellipse. And so you can see if I rotate around that blue dot, which is where our XY position starts. And then if I translate that blue dot and move the origin somewhere else, we're still rotating around the blue dot. So we rotate around wherever the origin of the canvas is. Okay, so let's look at an example of this. So I'm going to get rid of some of this stuff for a second. Whoops. And I'm just going to draw a new rectangle. And this time I'm going to draw it at 100x, 100y, and I'll keep the size as 100. Okay, so there's our rectangle, and we're going to rotate it now. And so remember, our rotation occurs here. So this is 0, 0. We haven't changed the default origin. And so when we rotate, we're actually taking this entire canvas. So we can think of the canvas as this little block. And we're going to rotate the whole thing around like this. And so what we'll see is that our shape is going to rotate around the origin point. Okay, so we'll see what that looks like. So I'm going to start, if I use rotate here, and I rotate by pi, so pi is just going to be a half circle rotation. The square goes away, right? Because our square starts here, but we're rotating from here. So if we rotate half a circle, we're actually rotating up to here. Our square is somewhere up there, but it's not in the canvas anymore, so we can't see it. So we have to be careful with our rotation to make sure that it's working correctly. So let's rotate by a smaller amount so we can see this working. So instead of pi, let's say pi, and let's multiply it by 0.1. So we'll get a tenth of a circle. And so now you can see there's our rectangle. So we rotated from here and we rotated just a little bit around to here. So we can still see our rectangle, but we can see that if we keep going, it's going to go off the canvas. So, pi is just a number. It's just 3.14 something something. So we can rotate by just regular numbers. Like I can rotate by 0.1. That's a slightly smaller number. I can rotate by 1. You can just see the edge of the rectangle there. So you don't have to rotate by pi, but it makes it a little bit easier to calculate, precise rotations. So if we rotate, let's rotate by 0 for a second and just leave it here. So one thing that we might want to do instead of rotating the square around, we might want to rotate the square either around its own origin, so like that, or we might want to rotate it from the center of the square. Okay, so we can do both of those things, but we have to use the translate function to get there first. And we need to apply the translate first. So we translate, so we're going to translate, we're going to move the origin to here first, and then we'll rotate. Because otherwise, if we do the rotation first, we're obviously going to rotate the whole canvas and not, well, we're always going to rotate the whole canvas, but we're going to move our origin point first. So this is actually going to be a little bit tricky. So the first thing I'm going to do is I'm going to translate, and I'm going to translate to the position where my rectangle is. But you're going to notice something. The rectangle is going to keep going. It's going to move down farther because now what we've got here, which we need to account for, is we start at 0, 0, okay? And we translate by 100. So 100 over on x and 100 over on y. And then our rectangle is at 100, 100 as well. So that's another 100, 100. So once we translate, we have to actually adjust our shape so we're not moving down again because we're going to end up with the same issue. So now I'm probably just going to rotate, draw my rectangle at 100, at 0, 0, which is going to be at 100, 100 with the new translation. And now I can rotate and we'll see the rectangle rotate around. So if I rotate by pi, our rectangle started here and we rotated around to here. And if we do something a little bit less than pi, let's do pi times 0.5, so half of pi. So now we get a quarter of a rotation. If we do 0.25, a quarter of a rotation, now we see we get this little diamond shape. So that's nice. We can start to see things that we weren't able to do before. So that's how we can rotate around the origin point. So we're rotating from here and we're rotating this rectangle around to here. If we want to rotate from the middle of the rectangle, we can do two things. We can translate, so if our rectangle is like here, we can translate even further, but we'll still have to move this part of the rectangle back. There's two ways to do that. We can subtract from x and y, or we can just change the rect mode. Of course, changing the rect mode is easier, so we could say rect mode center here. And so now what we're doing is we're actually rotating. The rectangle is starting here and we're rotating around that origin point. So we're going to get into this in a second, but I'll just show you a little bit of a look ahead of what this is going to look like. So eventually we're going to animate this. So we're going to start with a rotation R set to 0. And instead of rotating by pi, we're going to rotate by R. And then we can just change R. So we can say R plus equals 0.1, something like that. And now we'll get a cool animated rotation. We can slow that down a little bit to see that moving a little bit more. Of course, we can also speed it up. So we can add a bunch of different types of animations using this rotation. Of course, we could also go the other way just by saying negative R. So now we're rotating in the other direction. And then, we can use our conditional statements to control the rotation as well. But for now, this is just a little bit of a look ahead. Okay, so we have a couple more transformations to cover. Let me know if you guys have any questions as we go through. So just a note on how we measure rotation. Again, we're using pi just like we did when we were making our arcs. So pi is just a number. It's just 3.14 with a bunch of other digits after it. And it's just the number that we use in general in all math and geometry, not just in P5, to measure rotations. And we can do different stuff with pi. There's some basic constants that P5 gives us. So it gives us pi, gives us 2 pi, which is the equivalent of 1 full rotation. But we can also just use math to get those values. We can multiply pi or subtract or divide or whatever. Okay, so another thing we can do with transformations is scale. This one is pretty straightforward. We're going to scale into whatever the origin point of our drawing is. So if we translate to different places, like if we start at 0, 0 and we scale in, it's going to sort of grow from that 0, 0 point. If we translate to the middle of our canvas, then we'll scale into whatever the new origin is. So we can add this real quick. So we have our rotation going, and then the order of these things also, matters a little bit if I scale first or later. So if I scale before I translate, let's just scale to 2. You can see you get that. And if we move the scale after we translate, now we kind of shifted it a little bit. So the order of these transformations matters. If we scale first, we're scaling into the 0, 0, and then the rectangle is still kind of like offset from there. But if we translate first and then we scale, we're scaling right into the middle of that rectangle. So if we translate first and then scale, now we're getting to the rectangle. All right, so let's keep going. I think we have one more. So the last one we're going to cover is shear. And shear is probably the most complicated one. It's kind of hard to explain, but you can get some kind of cool effects with it. What shear does is it essentially kind of like offsets part of your drawing by an angle. So you can kind of see an example of this here. The shear value can either be on X or Y. And so what it does is it creates an angle, and so you can see how it's changing the drawing. And then once you create that angle, you can actually translate, up and down at that angle. So you can create some kind of interesting effects this way. It almost looks like kind of like a pseudo 3D effect. But basically what's going on, let's set this back to 0, if I can get it to 0. Okay, there we go. And then, so what's happening essentially as I increase the angle, you can see the angle that's being drawn here. And you can see that these 2 points don't really change. But what's happening is the relationship between these 2 points and these 2 points down here. And basically, these points are being offset according to the rotation of this angle. So we're sort of like rotating it. It's almost like 3D, but not quite. And so that's why if I translate this line, that middle line kind of stays the same, and the bottom line kind of stays the same. And then if I translate on Y, it moves on this new axis. So using shear is a little bit more complicated than using the other transformations, but it can give you some kind of nice effects. So here we see shear Y. Now we're applying the rotation to the Y dimension rather than the X. And then we get a slightly different effect. It kind of looks the same, but it's on the Y-axis instead of the X-axis. So you can see it's moving across this new X-axis, and it's moving up and down on the Y-axis, which hasn't changed. And I'll just show this example real quick. We can see X and Y next to each other. So I map these to the mouse. And so when the mouse is in the top left, we just get these 2 overlapping circles. And when I move the mouse all the way down to the bottom right, both of the circles completely disappear because we've rotated them to the angle at which, they're basically just 1 pixel. But, in between, there's these kind of like interesting different angles. You can get kind of a cool effect just by playing around with these functions. Okay, so the next thing when we are using transformations, as I mentioned earlier, these transformations are kind of additive. And so let's imagine for a second I wanted to create a sketch where I have 2 rectangles rotating around, in different places. I'm going to turn the scale off for a second. And so what I'm going to show here, if I wanted to have another rectangle, so let's say I have another rectangle and I just move it over. Sorry, I'm just going to move it over on X. And notice that they're both rotating around the same axis. So even if I move it over further, I'm still getting the rotation around this one point. So if I wanted two rectangles rotating around different points, what I would need to do is translate differently. And so this is where these other functions, push and pop, are really useful. I can save one transformation, and then I can go back to another one so I can undo the transformation without having to like translate backwards or do some other goofy stuff. So push and pop work a little bit, use a system that we haven't really learned yet, but they kind of obscure the system. So we really just have to learn the terms. We don't really have to understand exactly how the system works, but I'll describe it just briefly. So basically, the way that push and pop work is when we start our program, we have our canvas, and let's call this canvas 0. And the default canvas, has a scale of 1, and the XY origin is 0, 0, and the rotation is 0. These are kind of the default uh, settings of our canvas. When we do a transformation, we change those basic settings. And we can do that without doing any push and pop at all. But what we can do is add our transformations on top of each other in a little list, and then we can get rid of the transformation when we don't want it anymore. So if I make canvas 0 and then I say push, what I'm going to do now is that whatever updates I make to the next canvas, so let's say I move the origin here and I scale in or I rotate around or whatever I do in this canvas, what I can do after that is basically just say pop, and this will pop back to the original canvas or whatever the previous canvas was. So I can sort of stack these new canvas transformations on top of each other, and then I can go back to previous ones. So you can get really, really complicated with this. Like you can have lots of different transformations on top of each other. We don't want to do that quite yet. We just want to use a simple example. So again, I just want two rectangles that are rotating around their own centers. So what I can do is push before I do my first translation. And then after I draw my first rectangle, let's move the rect mode up here since we're just going to leave that as is. Um, After I do my first translation or transformation, I can say pop, and this will take me back to the original setup of my sketch. So see now this rectangle up here isn't rotating at all. It's staying in the same place. And so now I can add a new transformation. So anything that happens in between the first push and this pop down here, that basically just gets ignored. This won't get ignored, like the R will still be there, so we can still use that rotation value. So now I can add rotation to the second rectangle. So I can, after my pop, I can translate again. So I'm going to set this rectangle to 0, 0. And now I can translate again. This time I'm going to move over to 200 and keep Y at 100. Actually, let's move over to 300, give it a little more space. Okay, so now we've moved it over and we've got one rotating, the other isn't rotating, but we can add in another transformation. We can rotate, and this time we can still rotate by R. The variable value is not affected by the push and pop. The push and pop only applies to the canvas itself. Okay, so now I have two rectangles going in opposite directions. Of course, I can say negative R to make them go in the same direction, or just R. And then I can do this as many times as I want. So if I want a lot of different rotation animations occurring in different parts of my canvas, I can continue using push and pop. I can, do it multiple times. So let's see, let's move this down here so our rotation will kind of be on its own. And basically what I could do is just copy this whole section and translate to different places. So if we translated down here, so now we have three different rectangles rotating. The last one I don't have to push and pop just because there's nothing that comes after it, so I don't have to worry about affecting the next translation. But, if I didn't do these push and pop, let's say I take these pops out, now we're getting these, different rotations that are happening on top of each other. There are some kind of cool things going on because I'm rotating multiple times, so you might want to play around with that. But a lot of this stuff is happening off screen because we're not really controlling exactly what's going on. So we have to be a little careful there. Oh, did I get an error? Oh, no, it just took a little while to load. Okay, so that's push and pop. That one's a little bit trickier. Hopefully that basically makes sense, but it's just to go over if you want to have multiple different transformations going on, you can do them without having to reset the whole thing. So I think we already went over this. Let's look at animation. I guess we basically have been doing animation this whole time, but let's do one with our our meme. So let me see, where's my meme? It's over here. Okay, so I'm going to simplify this just a little bit. I don't want this mouse X thing happening here. So let's just put the dog image at 0x and 400y. Okay, maybe it's just 300y. Okay, so we've got our cat, we've got our dog. We do already have an animation with the dog, but I'm just going to get rid of that and we'll do a different one. Oops, I still need to have an X value here. Okay. So in this one, again, you can animate anything. I'm going to animate the text just as an example, but you can animate the image, you can add shapes, you can really animate anything that has these basic components, whether it's position or size or rotation or whatever else it is. But let's use shear just because it's kind of fun and it's a little bit more tricky to use, but you'll see that it's actually not too bad to implement. Um, so what I'm going to do is just apply this to the text. So let me simplify this a little bit. I'm going to move all of my text related stuff into the setup function so I don't have to look at it up in my main draw function. And then I'm going to animate these two different texts differently. So let's start. I need a variable. So I'm going to start with a cat rotation variable. I'll set that to 0, and then I'll have a dog rotation variable. So that's also 0. And so this works in the same principle that we looked at on Monday night. If we're going to animate something, we are basically automating the interaction. So when something's interactive, we can track where the user's mouse is, and then we can just get a number from that. But when something's animated, there's nothing changing, so we have to drive the change. So we have to take a number and move it somewhere, move it back, do different manipulations with it. So let's start with our cat text. So I'm going to have to translate to where the text is first, because as we saw with the other example, if I try to rotate or do something from the origin, it's going to be going mostly off the canvas. So we're going to first translate to where the cat is. So I'm going to take this 200 and 250 from the cat text, not the image, and then replace this with 0, 0, since we're translating over there. We need to make it 0, 0, so we translate and then we're drawing the text at 0, 0. Okay, so next we're going to apply a rotation, or actually let's do a shear. So I'm going to do shear X, and I'm going to do it by cat rotation. So now we have to update the cat rotation because otherwise this won't change anything. So I'm going to say cat rotation, and let's just add a little bit to it. So let's add a small number like 0.01. So now the shear X kind of like flips all the way around. So that's pretty cool. But I want to control it a little bit more. And so I can do that using pi and using some other stuff. So instead of like flipping all the way around, I could just leave it like that because it's kind of cool. But if I want to control the animation a little bit, I can test to see if I've gotten, to a certain angle. And then I can go back the other direction. So to do that, I'm going to need to use my speed value like I did on Monday. So I'm going to add another variable. Let's collapse these functions just to clean this up a little bit. And so let's say cat speed, and I'll put an R here for rotation. And so we're going to start with 0.01. And so now I'll just say if cat rotation is greater than pi, we're going to flip it around. So first we're going to say cat rotation plus equals cat speed r. I guess it's really better to say r speed. I could say rotation speed. I guess it's not too long. So we'll say cat rotation speed, and I'll replace this up here. That looks a little bit better. So if we get to pi, we'll say cat rotation speed multiplied equals -1. So we talked about that on Monday. Just to quickly re explain that, essentially whatever the speed is, so if it starts as 0.01, and I'm using a small value here because we're dealing with rotation rather than position, if I multiply this by -1, which is what times equals -1 does, it multiplies it by -1 and then reassigns it to the variable. If I multiply this by -1, I get -0.01. If I multiply that by -1, I go back to 0.01. So basically, we're just going to toggle between rotating to the left and rotating to the right. Okay, so let's give that a shot. So we're going to rotate, and then when we hit pi, it starts to go back the other way. And so we're also going to want to stop it when we get to 0. So we're going to say, here's just a review of our compound statement. So we're going to say if it gets to pi or if it goes back to 0. So the or is the two lines, the double pipes. So or cat rotation is less than 0. We're going to flip it back around. So we're going to rotate around one way and then back. And we can change it. So right now it's going all the way, but we don't have to do that necessarily. We could make it a smaller value. So we could say like, pi times 0.5. And so now it won't flip all the way around. So it kind of like hits and then bounces back. But then it gets to 0 pretty quickly. So we'd have to increase this value. So we'd have to say negative, we'd have to basically go the same direction, like negative pi times 0.5 over here. So that's kind of fun. I don't know how useful it is, but that's just a quick example. And then we can basically do the same thing with the dog rotation. So let's add a speed up here, say dog rotation speed equals 0.01. And then notice that the dog text is like all the way out of frame because we've translated up here. So we're going to have to push and pop to get rid of this translation. So we'll say push up here and pop down here. So now we get our dog text back. So now we can do something different. So actually, I don't need to push and pop. Here, I'll translate again. This time I'm translating again to where the text is drawn. So I'll just copy and paste that in there and then change this to 0, 0. I guess this is basically just the same thing. And then we can do shear y by dog rotation. Or actually, we need to do that before we draw the text. So I'm just going to move that up. And then we just update our dog rotation. So we say dog rotation plus equals dog rotation speed. You don't have to have two of these. I just happen to have two of them. So we get a different effect with the shear y. And of course, you can go through and add the whole thing. I'm going to not do that for now because we're getting pretty close to when I want to wrap up. And I do want to go over doing a little bit of documentation again. So I'm going to leave it like this, and I'm going to document it. So I'll just review this. Of course, we have gone over this a couple of times, but I think it's good to review. So I still have my mouse pressed function down here to save an image. Since there is an animation, I'm going to want to save a couple examples of this. So I'll just click on here a couple times, and I want to just kind of capture a few different points. And now I can post that on the Open Lab. So I'm going to go over to the Open Lab for the class. And I need to log in first. And so once I'm logged in, I can hit the plus button for a new post. And I want to choose a category first. So I'll look for the animation category. So this is assignment 7, animated logo / meme. And I'll say my animated meme. And so here I'm just going to dump all of those screenshots that I just took. So I'm just going to hit plus here and then add a gallery and click upload. And these are all just in my downloads folder. So I'll just select them all and throw them in there. And so that's a pretty easy way just to add a bunch of images at the same time. If I want to update the gallery. It's kind of I don't know why this is so hard to choose the gallery, but I think you have to click on one of the images and then click on this menu and click on select parent block, which is the gallery. And once I do that, I can either put all the images next to each other. They're kind of small that way, so I could, make them like that. It doesn't really matter. You can kind of do it however you think makes sense. Um, I guess they're kind of small, but at least you can kind of see what's happening with the rotation. You can also turn on or off crop images. You can try different stuff with that. And then, of course, you're going to want to include a link to your code. So I'll just say my animated meme rotates the text for the dog and the cat. And here's my code. And when you paste in the code, you just want to make sure not to choose the embed option. So I'm going to paste that in and then turn this into a link. So I'll just click link here, open a new tab, and there we go. Can preview that real quick. Okay, so that looks pretty good. And once you are happy with it, you can click publish. And once you publish, you're going to get the link here, and that's the only thing that you put into Blackboard. So you just take the link, you can copy it here, or you can click View Post, and it's going to go over here. So you just copy that and just paste that link into the Blackboard. You don't have to post anything else in Blackboard. Okay, so that's just a quick review of how to document the assignment. Um, and I think that covers everything. So let's just go back to the assignment real quick. So this is under week 7. So just take your animated meme or logo. You just have to animate one particular part. So if you want to add multiple animations, that's great. But you don't have to have multiple animations. You can just animate the size, position, or color. You can also use translate, rotate, shear, or scale. Any of those things. There's a lot of different stuff that I didn't get a chance to show. So you could do other stuff, like you could use the scale. That's a good way to do it. Let me see if I can give a quick example of that. Like if I just change this to scale, and I'm not changing all the values exactly, but yeah, so you can animate the scale, so you can kind of zoom into the text. So there's a lot of different things you could do with that. If you have different ideas of stuff that you want to try, let me know and we could go over it. So I'm just gonna undo this. Actually, it's kind of cool. I'll do dog scale instead, and dog scale speed. And let's add this in here. So we'll say scale, dog scale plus equals dog scale speed. And then we can do a similar thing. We can say if dog scale is greater than 2, dog scale speed, just flip it around, multiply the speed by -1. So when we get to 2, we're going to go back down. Then, of course, we don't want it to go to 0. Eventually, it flips and reverses, which is kind of a funny quirk of P5. But we don't want it to get below 0, so we can put an or in there and say or dog scale is less than 0. So this will prevent it from getting too small. And so now we've got a little scale-based animation. So there's a lot of different stuff you can do with it. You don't just have to use, the basic position or things like that. All right, I'm going to stop the video here.